So for part number 1, it says suppose that f prime is greater than, and this is like an average, this is like a slope of a secant line from A. So what this is saying is that the slope of the tangent is greater than the slope of the secant. Which of the following could be the graph? So if I look at A here, the slope of the tangent versus the slope of the secant, I can see that the slope of the tangent is greater. So 1 is a possibility. On here, on A, if I look at the slope of the tangent versus the slope of the secant, it looks to me like the slope of the secant is greater, so 2 is out. This one is a little bit different because we have negative slopes. So I have the slope of the tangent is here and the slope of the secant is here, but the slope of the secant is closer to 0. So for negative numbers, being closer to 0 means you're bigger. So the slope of the secant is closer to 0, so this one is out because the slope of the tangent is actually smaller than the slope of the secant. And here I have the tangent line is here, and the secant line is here, and the slope of the tangent is closer to 0. So it's negative, but since it's negative but closer to 0, that means it's bigger. So 4 is 1, so it's going to be 1 and 4 only. For this one, I want to evaluate this, and I can see that this is the definition of derivative with pi over 2 plugged in. So what I need to do is I need to take the derivative of cosine x, and then I want to plug in pi over 2. So the derivative of cosine x is negative sine x, and negative sine of pi over 2, so that's negative 1. Because if I think of the normal sine function, it looks like this at pi over 2, but I want to flip it over, so I'm going to get negative 1 there. So that's B. Then this says if the integral of from a to b of g of x is 4a plus b, then the integral of g of x plus 7, well, I can split it up and be the integral from a to b of g of x dx plus the integral from a to b of 7 dx. And so this I know, I've already integrated that. That's 4a plus b plus, and then the integral from a to b of 7 is going to be 7x evaluated from a to b. And so that's 4a plus b plus 7b minus 7a. And so I can see 4a minus 7a is negative 3a, and b plus 7b is plus 8b. So negative 3a plus 8b is here. So here I have the derivative function. So let's remember this is the derivative of f. So based on this graph, the function y equals f of x is increasing on which intervals? So I'm just going to draw this out on a number line for my f prime function. F prime is 0 at negative 1, 1, and 4. And f prime is positive here, negative, positive, negative. So that means that f is decreasing, then f is increasing, f is decreasing, f is increasing. So we know that f is increasing on the interval negative 1 to 1, union 4 to infinity. So that's it. That's part B. The function f is continuous on the closed interval negative 2 to 1. Some values of f are shown in the table below. And then it says the equation f of x equal 3/2 must have at least 2 solutions in the interval negative 1, 1 if k equals what? Okay, so I think it will help if we plot these points. So if we do negative 2, negative 3, and then -1, 7, and then 0k, let's figure out where to put that later, and then 1, 3. Okay, good. And so what I want is the equation f of x equal 3 halves. So 3 halves is here. This is 3 halves. And so I want f of x equal 3 halves to have two solutions on the interval from -1 to 1. And so for that to have two solutions, that means it needs to drop down below there and then drop back up, right? So k needs to be any value less than 3 halves. So k must be less than 3 halves. So let's see if we can pick a number, which is about 1.5. So let's pick a number less than 3 halves. So 3, 5 halves, 2, 3 halves. So 1 is the only one that's less than 3 halves. And so if k equal 1, then I know I'll have two solutions to f of x equals 3 halves on the interval from -1 to 1.